Let me explain the next CCNA lecture, and today I'll cover the what is the bridge, what is the switch, what is the difference between switch and bridge, how they will work. Yeah? So this part we will cover. In the last lecture, we have discussed about the hub. So hub is it is single collision domain and single broadcast domain. Yeah. It means in the hub collision take place as well as the broadcast will take place. Both will be happen in the hub. But let me explain. After hub, the engineer developed the bridge. Yeah. Means the one device it is developed, and the similar like that. Yeah, similar like that. The hub it is similar like that. It is developed the one box. This box having the the hub having the single collision domain. It means that the collision will take place, but the engineers the developers is changing here. It is the hub is the like electronic device, so it is something like change. Yeah, it is it is the single collision domain. It means collision will take place in hub. Yeah, but in this device it is logically divide the channels. Yeah, logically divide inside of that box. It is logically divide the suppose this is the PCA. Yeah, this is the PCB. Yeah, this is my PCB. Yeah, and this is the PCC. Yeah, and the next one is the PCD. Yeah, so if PCB want to communicate with PCC, so it is having the separate using the programming like C++, means it is the software base. Yeah, what do you mean by the difference between the software and hardware? If I'm talking about the, let me take one example. If in the kitchen there is the single lady prepare the food, so what happened? First she prepare the rice, after that she prepare the chapatis, and they then pulses. Means the steps are serially if single lady is there. But in place of the single lady, if there are two ladies are come in the kitchen, so after that the work will be parallelly. One ladies prepare the chapati, another ladies prepare the rice. Yeah, so work will be parallelly performed. If any task is parallelly, it is the fast. If any task is the serially, it is the slow. So same like difference in the software and hardware. If I'm talking about the software languages like C, C++, Python, Java, yeah. Let me take example of the Python. Python is very easy language. I have also teach the Python. Yeah, during the network automation, I have teach the Python. But let me take example C, C++. That is the basic language. Yeah, which is start from the in your doing the graduation. So you learn C, C++. If suppose I'm adding the two number a plus b equal to sum, so in that case what happen in the C++, what this is the software based language. This is the software based language. Software. So in software, how I can return? First, I return the like scan A, yeah, and given the input. After that, I write down the scan B and given the input, yeah. And after that, I need to write down the function s equal to a plus b, and I need to print the s, yeah. So this function perform this serially, means first A will execute, after that B will execute, after that function will execute, after that print will work. Yeah, so that function perform the serially. So if any task is serially, always be slow. Yeah, if any task will be uh, parallelly, it will perform the fast. So software disadvantage is that it is always slow. Yeah, when I also teach means I also told you I'm teaching the Python or network automation. When we push the configuration in router via Python script, via Ansible, via Terraform, so it will take too much time. Yeah, like 10 minutes, 15 minutes, depend on the location and where your server is hosted. Yeah, So it is very slow. Yeah. But if I'm talking about the hardware language, hardware like embedded, VLSI, yeah, VSDL, these are the hardware language. Those from the electronic and telecommunication background, they know these languages. Yeah, embedded, VLSI, VSDL. Yeah, I know VSDL. Yeah, in my I was doing the some of the project. On that project I use the VSDL. Yeah, so in VSDL, if suppose I'm adding the two number, if suppose A plus B equal to S, yeah, I need to add two number. So that is called the half adder. In the half adder, there is the gates are there, AND gate and the OR gate. Yeah, and here are the my inputs are there. Yeah, here is the A input, here is the P input. On that time, it is come sum equal to A plus B, and here is the carry will come. So this function A plus B comes parallelly. After that, sum and carry will become. So that will perform parallelly. 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 So whenever any input come parallelly, so output it automatically come very fast. Yeah. So if any task is the parallelly, so output will be very fast. So all the hardware languages, yeah, as I explained you, VSDL, embedded, PLSI, these are the hardware language. All are fast, yeah, but software language are very slow. Yeah. So bridge architecture is the means this device which is connect the all the PCs. That name is the bridge. Yeah, and that the name is very good. Yeah, because if suppose this is the my one router, means this is my one road. Yeah, and this is my another road. In between that train is coming. Means train is coming in this side. Yeah? So if I want to add two roads due to train, the traffic will stay this side, this side. Yeah. So we need to clean up the traffic. So after that, government is create one kind of flyover here. Yeah. So whenever any bus or any car will come, automatically it will drive on the on the road. Yeah, and it will exit. So bridge means two roads are connected to each other using the bridge. Similar like that, if computer A, B, C all are separated and this computer are connected via one device, that device name is the bridge. Yeah. So this is my bridge. Yeah. This name is the bridge. Yeah. Bridge. It is no more in the network. Hub and bridge is not there in the current network. But I'm telling you how the network was developed. Yeah. So the bridges come in that picture, and the bridge architecture is the software base. Yeah, is the software base. So any PC want to communicate, so the traffic come to the bridge. After that, it will come to the C. Yeah. So using this pipe, yeah, separate pipe. Yeah. So the engineers design these pipes using the software based languages. Software based means C, for example, C, C++. Yeah. So it is used the software language to segregate the lines, to segregate the communication. Yeah. Suppose A want to communicate with the B, so it is separate pipe. Yeah. B want to communicate with the C, it is separate pipe. Yeah. Everywhere it is create the separate pipe. Yeah. So it is having right now means the suppose we have the separate road, so accident will not take place. Similar like that, the separate pipe are there. If this one send the data, so separate pipe is there. Yeah, this one send data to here, separate pipe is there. So here there is the no collision because there is the log means physically shared medium, but logically they are isolated. The all cables means inside of the bridge, the all path are segregated, means the data won't collide. Yeah, won't collide. So here is the there is the no collision is there. So that's why this area is different, this area is different, this area is different, this one is different, every area is different. So that's why it is called the multiple collision, collision domain. Yeah. As I explained in the last lecture, the single collision domain, it means the single collision domain, it means the single, yeah, it means collision will take place. Yeah, because there is the single road, single collision. Yeah, here is the multiple collision domain, means collision won't take any, means won't happen here. Yeah, it will won't happen, and the traffic is there is the no collision, means I can say collision will be eliminate here. Yeah, not avoid. Avoid means temporarily relieve, but eliminate permanently finish. Similar like that, the collision, multiple collision domain, it means it is permanently remove the collision. So bridge having the multiple collision domain, yeah, and bridge having the a single broadcast domain. Broadcast domain. It means that it means that broadcast will take place. Broadcast will take place. It means that if someone send the data, yeah, so whatever the inside collision domain are there, suppose 4 port are there, so it will create a three copies. Three copies, one copy sent here, one copy sent here, one copy sent here. It means that whatever the ports are there, n minus one, means it is always doing the broadcasting. I'm not going in the deep how many copies are created, but whenever the data is coming, it will send to all the ports. All the ports. So in bridge, broadcast will take place. Single broadcast means broadcast will take place. Yeah? In own words classes, I will explain multiple broadcast domain. It means broadcast won't happen. But here is the broadcast will take place because the one PC send the data, all are receive the same copy. So in the bridge, broadcast will take place, but collision won't happen. Yeah, see, multiple collision domain is there. Yeah? So bridge is very good as compared to hub. It is very good because it is having the single multiple collision domain. That is the best advantage. Yeah, but the problem is that its architecture is the software based. So that's why bridge is the very slow. As I explained you, whatever the software thinks, it is very slow. Yeah. So that's why engineers develop the new thing. Yeah. He developed the new thing. He developed the new thing, similar like the bridge. Yeah. It is create the same box. Yeah. It is connect the same PCs are there. Yeah. Same PCs are there. Yeah. Nothing difference. Yeah. This is the PCA. This is the PC. This is the PCA. Let me bigger the computer size. That is the PCB. This is the PCD, C and D. Yeah. Same PCs are there, but in this box, it is created the logical pipe here to here, here to here. So collision won't take place. So it is created a logical pipes are there. Every PC communicate to each other. So that logical division, not in the software programming language, the logical difference is logical pipes are created using the hardware language. Hardware language, it is created the separate pipe. Yeah. So that box architecture is the hardware base. Hardware. It is the hardware base. So that's why it is very fast. Yeah. Very fast. And it is in the millisecond, it is switch the network. It is switch the traffic. In the millisecond, the switching the traffic, that's the best feature. So that's why its name is the switch. Yeah. That box name is the switch. Yeah. So that box name is the switch. So as compared to the bridge, yeah, it is the way switch is very good. And the name of the switch is the switch. Yeah. It is switching the data. Yeah. So that's why its name is the switch. Its architecture is the hardware. Yes. And bridge architecture is the software. Its architecture is the software. So that's why it is slow. Yeah. But bridge is very fast. So in during the interviewer asked, yeah, but let me explain before difference between switch and bridge. Let me explain the switch things. Yeah, the switch is similar like the functionality wise, similar like the switch. Yeah, it is having the multiple collision domain and single broadcast domain. Nothing difference. Single multiple collision domain, it means collision won't take any place. Means collision won't happen. Yeah. But single broadcast domain means broadcast will take place. Whenever any PC send the traffic, it will send to all the PCs. So broadcast will take place. But the collision won't take any kind of means won't happen collision. Yeah. So it is also collision free. So what is the difference between the switch and bridge? Yeah. So that question asked in the interview. Yeah. What is the difference between the bridge and the switch? Yeah. So the basic difference is, first difference, its architecture is the software base. Software base. And its architecture is the hardware base. Hardware base. Yeah. Hardware base. That is the first difference. And the second difference is that it is the software based. So that's why it is very slow. Yeah. That's why it is very slow, because its architecture is the software based. So it's very slow. So what happened? It is very slow. So that's why we cannot add more code. Yeah. So bridge generally have the 12 port bridge, 8 port bridge. Yeah. So it is having always minimum port, because it's already slow. Yeah. If any person is very old, like 17, 18-year old, if we are given the lot of tasks in our office, do this, do this, do this, he will not perform very well, because its age is 17. Yeah. So its hardware is very slow, its architecture is very slow. So that's why it will perform the serially. So it's very slow. But if we are hire the younger people, like 20 years, 21 years, 22 years, they are very fast, because its architecture is, because they are young. So they are parallelly perform. So similar like that, switch, we can assign the many port here, but bridge already slow. So that's why it's having the minimum ports. Yeah. But switch having the maximum ports. Yeah. In switch, 24 port, 48 port. Yeah. 96 port switch also there. So it is having the maximum ports. Yeah. Lot of ports added. Yeah. So that is the second difference. And the third difference is that it 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 is the software based. So that's why it is means the virus are written in the software. Yeah. And the switch architecture is software. Yeah. So the virus will impact the bridge, because its architecture is software based. The virus is also written in the software. So it will impact the bridge. It will impact the bridge. So for like our PC, for PC software based, so in our PC, virus are impacted our PC. So that's why we install the antivirus, we install the patches. Similar like that, we need a extra PC for the management, for the maintenance, maintenance. For the maintenance, we need extra PC, because it will impact from the viruses. So for us, bridge management is very difficult, because every time we need to upload the antivirus, we need to upload the patches. So extra PC we need. Yeah? That is the disadvantage. So it need an extra PC, extra, extra PC for antivirus and patch management. Yeah? But it is the hardware base and the virus written in the software base. So nobody can harm the switch, because its architecture is hardware based. Yeah. Software means the virus won't affect here. Yeah. So the similar like that, there is the no extra PC here, because we do not update the antivirus or patch upgrade or anything. So no extra PC are needed. That is the also advantage. Extra PC. No extra PC are needed, because it won't affect it from the viruses. Yeah. So that's why in the market only bridge is used, only switch is used in the market. Bridge is no more there in the market. In the IT sector, we are not using any kind of bridge right now. Yeah, everybody use the switch because switch is very fast. Its architecture is hardware based. So that is the basic difference between the switch and bridge. Yeah? In the next lecture, I will introduce the router. Yeah, because the switch having the single collision domain. Multiple collision domain and single broadcast domain. It means broadcast will take place here. So I have explained full mesh. After that, bus topology. After that, I have explained the why hub is come and hub having the single collision domain. That's why bridge come in that picture. And bridge is very slow. Yeah, very slow. It's a software based. Its architecture is software based. That's why the switch come in that picture. And switch is the perfect. It is used in the network current time. Yeah, everything is good. But the problem is that it is a single broadcast domain. Yeah, that's why we use the router. Yeah? So in the next lecture, I will explain you about the router. Goodbye. Thank you so much.